we want to go ahead and get started, and I appreciate those of you who are joined us today. My name is Ann Adrian. I am located at Auburn University, and I'm part of the Hunger Solutions Institute, which is based here, and I'm part of the Presidents United to Solve Hunger. And this is an initiative where presidents of universities have signed a commitment to have efforts within their university with the idea of solving hunger. And those things can be anything from student engagement, outreach, research, and even instruction. And as part of my role as the Open Data Project Manager, we've been working with GODAN, which is the Global Open Data for Agriculture and Nutrition. And our project specifically right now is assessing the readiness of universities to share their research data openly. And this is becoming a bigger, a more important thing to do, but particularly as it has to do with complying with funders. In this partnership, we are working with Medha Devare, our speaker today, and as she's part of CGIAR. And she was going to share with our working group here at Auburn, as well as some of the people at GODAN, her presentation that she's was doing around their big data platform. And instead of just giving it to the small working group we had, we decided to open it up as this webinar. And so I'm really excited that you all have joined us, and we hope to learn from you as well. And so feel free to ask questions. You can ask questions in the chat. Right now your audio is turned off, but if you want to ask questions verbally, just raise your hand or tell me in chat, and I will open up your microphone. So I'm going to go ahead and get started. Medha Devare is a senior research fellow with the International Food Policy Research Institute and module lead of CGIAR's big data platform based in Montpellier, France. She is a cropping systems agronomist, a microbiologist, ecologist with significant experience leading projects addressing food and nutrition security and sustainable resource management in South Asia. Medha also has substantial experience in data and knowledge management, including ontologies, vocabularies, and semantic web-related tools. Before she moved to France, Medha was a scientist and knowledge management specialist at the International Maize and Wheat Improvement Center based in Nepal. There she led the USAID-funded Cereal Systems Initiative for South Asia and Nepal to increase the productivity and profitability of small farmers and the sustainability of farming systems in Western Nepal. The Cereal System Initiative focused on developing options for small holders, including the seed sector, best bet field management, and small-scale mechanism for rice, lentil, and maize, coupled with efforts to strengthen value chains to operationalize these options. Prior to her position at the International Maize and Wheat Center, Medha was a life science librarian, bioinformatics specialist at Cornell University, where she received her PhD and conducted postdoctoral research. We've been working with Medha for several months now, and it has just been very enlightening to us, and learning so much about not only the importance of open data, but creating systems that make this research data discoverable and useful. And so I'm thrilled that Medha's given this webinar today and working with us. And it is already evening for her, so we appreciate her time and in her personal life that she's taken to do this. So thanks, Medha, for joining us.
You're very welcome, and welcome to everyone who's attending. I'm pleased to see that I know at least one of you from Cornell. Hi, James, it's good to see you there. I will guess I'll launch into my presentation without much ado. I'm assuming you can all see my screen now? Yes? Now?
Yes, I can see it, so I think not hearing otherwise. So.
Good, excellent. And what I might do is just, I'll keep myself on video unless the connection gets really wonky. and then I'll turn it off if it does to conserve bandwidth. So as Anne said, I am now leading, I think she said this, I don't remember what I put in that bio exactly, but I'm now leading one of the 3 modules of CGIAR's very new big data platform. This, or as it's more correctly known, is the Platform for Big Data in Agriculture. This platform is co-led by 2 of our 15 centers. The administrative lead on this is CIAT, the International Center for Tropical Agriculture, which is based in Colombia, and IFPRI, which is the institution I'm affiliated with, which is based in Washington, D.C., the International Food Policy and Research Institute. I'm based in Montpellier. I have the hardship post of the lot. And I work from here for now anyway. And so what I'm tasked with, I'll talk a little bit more about what I'm tasked with, but this work that I'm doing now is a sort of a continuation of the Open Access and Open Data initiative that was something that I was leading through a very large Gates initiative meant to encourage open access to publications and to data, essentially to final research outputs of CGIAR across all of our centers. So with that, let me just move on, if I can make this move on, which it doesn't seem to, there we go. I just wanted to quickly talk to what CGIAR actually is. For those who don't know, we are 15 nonprofit centers focused on agricultural research for development. Most of our centers are in developing countries, with the exception of, I guess, 2 primarily, Bioversity, which is based in Rome, and IFPRI, which is the one I'm affiliated with, which is based in Washington, D.C. But I don't know how well you can see this map. It doesn't matter what the center names are, but you should see those orange dots, and that tells you a little bit about where we are. We have about 10,000 scientists, support staff in over 70 countries. The centers themselves work in very close collaboration with both national and regional partners, research institutes, as well as private sector, civil society organizations, academic institutions, extension organizations, and other development organizations as well. But with 15 centers that are geographically dispersed, and each of them has their own board, essentially, it becomes rather a difficult proposition to work across them, really. But increasingly, we are trying to work more and more collaboratively with each other as well. And we now have a new strategy and results framework that essentially focuses on 3 thrust areas: reducing poverty, improving food and nutrition security, and doing so while at the same time sustaining or ideally improving natural resources and ecosystem services. But all of these 3 strategic goals that we have are in turn mapped to many of the UN's Sustainable Development Goals. So that, in a nutshell, is CGIAR. I'm going to jump now from what CGIAR is to the big data platform itself. The platform is new in this year's CGIAR Research Portfolio, or CRP portfolio. The CRP portfolio is sort of a portfolio of projects, proposals, or really collaborative projects, very large collaborative projects that are globals in their reach, led by one or more center typically, and the platform is one of 3 platforms. And the big data platform is new this year, along with the excellence in breeding platform. There are, as I mentioned, 3 platforms: the excellence in breeding platform, which is new, the big data platform, which is new, and the gene banks platform, which used to be a program, a collaborative research program, CGIAR program, but has now been sort of become more of a platform because it's supposed to work across all of the centers, all of our 15 centers. The big data platform itself is organized around 3 main pillars. organize, convene, and inspire. And the organize module or pillar is the one that's most heavily resourced, and that's the one that I lead. That's sort of the continuation of the open access and open data push across CGIAR. And it aims to basically support best practice or good practices in data stewardship writ large and enable fair data. What I mean by fair data is the FAIR stands for findable, accessible, interoperable, and reusable. And particularly the two last bits are I think, particularly important. Of course, resources have to be findable and accessible, but for them to be truly reusable and truly useful from a research point of view and from the point of view of innovation and impact, they really do have to be interoperable as well. So that's something we're focusing on increasingly rather than just talking about open. It's sort of a move towards a more nuanced or almost a clarification of what do we mean when we say open? What exactly are the components of the word open? The Convene platform or the Convene pillar recognizes that at CGIAR is research for development. We tend to be a bunch of researchers primarily, all the way from germplasm development, lab work from at the genetic scale really, all the way through to people who work in the field and geospatial scientists who are working with landscape level satellite data, remote sensing data, etc. But they tend to be, it tends to be very research focused. We don't have the IT capacity really, as we ought to be able to realize the vision of what big data can do for us. And so the idea of the Convene pillar is to bring together the right kinds of partners, build the partnerships in order to fulfill the vision that we have. And that could be across sectors. It could be academia, it could be private sector, it could be other development, it could be development organizations, it could be other international organizations. The inspire part is the part that truly sort of lets us realize the value of making our data, putting our stuff, our research outputs into the open domain. It's the so what part of it. It's the use of analytics and ICTs tools essentially to do everything from be able to analyze data and do innovative, build more innovative solutions out of the data we already have, to deliver information to farmers, to be able to monitor agricultural and food security and allow donors and funders and policymakers really to be able to do some foresight analysis. I see that there's a chat here, and I hope it's not that you can't hear me. All right, question, I'll keep that for later right now, but just feel free to tell me if you can't hear me or if the connection's not good, at which point I'll turn off the video and focus on just the audio.
So far, it's very clear for me, Medha.
Good. I hope that's true for everyone. All right, so moving on, if I can move on, this thing always is really kludgy. Okay, here we go. We're talking about big data, but what do we actually mean in this context when we're talking about data? And I found this schematic online. I've cited where I found it, but I really like it because it allows me to sort of relate what we're talking about to our situation with the big data platform. The platform itself is focused primarily on agronomic and socioeconomic data. These are really sort of trouble areas for us. It's fairly clear that in terms of the genetics level information, there are good solutions already in existence, and they've been in existence for decades, some of them, a couple of decades or so. And so for agronomic and socioeconomic data, which tends to be very heterogeneous, very unstructured often, particularly for socioeconomic data, this can be a real issue. What we're often talking about is my data, which is, I'm an agronomist, I've collected data. It's not, I wouldn't consider it to be big data at all. It's little data, really. When I share it, say with my team, of course it becomes shared data. So we're moving along a continuum here. And then when I'm able to aggregate data across a few people, and it's still connectable back to me, we might consider that to be aggregated data. But what we're really talking about here is a sort of depersonalizing, combining data from multiple sources. It may or may not be connectable back to the user. Ideally, it would be for the user to realize, or for the generator, pardon me, to realize some value out of it. But that's really what we're talking about when we speak about big data. It's creating that pool of aggregatable, aggregated, combinable data. So I like to make that clear, because it's not big data in the sense of, astrophysics data or the collider data, that kind of stuff. We're talking about something slightly different. So I'm going to talk a little bit. I'm going to focus for the rest of the talk, of course, on the module that I'm leading and the efforts that I'm leading. Again, that are continuation of a work that was really begun in about 2015, and that is supporting best practices in stewardship, and trying to recognize that needs to be done from the point of data collection, and not typically as we do it right at the very end, after the data has been collected, after it's been described in whatever way it's been described, etc. We're trying to approach it from the beginning of the data collection, or the data life cycle, really. And then a key piece of what the platform's trying to do is to enable the discovery of that data, and its reuse, and of course, very importantly, its interoperability. Why are we doing this? To allow the aggregation of and combining of data sets that we need in order to answer the kinds of questions, the large, big questions that we're trying to answer, that relate to climate change, that relate to other issues having to do with both productivity of farming systems and profitability thereof. All right, so again, to reinforce the message, technologically, we have a lot of capabilities at our fingertips. What the challenge for us lies in being able to aggregate, to integrate, to manage our data, to describe it in ways that allow this to happen. So, and what are we talking about? We're talking about a variety of different data types. We're talking about weather data from different sources. We're talking about management data, whether that's crop management, whether it's irrigation or anything else. We're talking about input and output markets. And increasingly, we're talking about remote sensing data. We're talking about satellite data. We're talking about drone data. So all of this, in order to derive actionable information from the work that we do at CGIAR, we work primarily with small farmers. We work on farm, and we do experiments in the field. But how do we put all of these different streams of information together in order to be able to give farmers to answer the kinds of questions that they ask, and that's really where the challenge is. So, technologically, of course, as I said, this is possible, but there's a large gorilla in the room, or maybe several of them, and of course, a lot of that has to do with we're talking about sort of big data highway. What we're dealing with looks more like this, a very potholey, very narrow sort of road with not many on-ramps or off-ramps yet. We're trying to build all of that. And so creating that big data highway is a huge challenge. One of the biggest challenges we have has to do with data quality. And that's in terms of the quality of the data sets themselves that are collected, but also the way in which those data sets are described, or the lack of metadata, often the lack of standardization in terms of column headings for data. I mean, I've been talking a lot about aggregating data. I've been talking a lot about integrating data. You can't do that if every data generator has a different way of calling the same thing, obviously. So those are some of the issues that we are trying to address through the organized pillar of the big data platform. So in terms of data discovery and quality, I'm just going to throw up a few things that we've done. One of the first things that we tried to address was each center, each of our 15 centers, typically has one data repository and one publications repository. And they tend to be different platforms. They are different platforms for every center. And the metadata schemas are different. There's no sort of required metadata in the lot. And so this becomes a very thorny problem when you're trying to expose the resources, the research outputs from all of these centers. So the first thing that we did through the Open Access and Open Data Initiative was to develop what we call the CG Core, CG for CGIAR, CG Core metadata schema, of which there are a few elements that are absolutely required, and others that are recommended but not required, or required depending on the kind of data that we're talking about or the kind of resource that we're talking about. So most centers, all centers now have either implemented the schema or can map to it effectively in their repositories. So that's a very good thing. For some of the centers who were not using sort of standards compliant repositories, all of the centers now have moved to standards compliant repositories. So that's another a good move that came about as a result of the Open Access and Open Data Initiative. And as I'm talking through this, I should also mention that, I started out, as Anne mentioned, my exposure to data and to managing resources came about through my work at Cornell, through my work at Mann Library. So I was fortunate enough to be exposed to some library concepts, which I didn't know much about because I came from the scientific world, really. But I was also able to, because I was tied into sort of the bioinformatics specialty, I was exposed to the biomedical world and genetics and genomics world, which taught me a real lot. And right from that point onward, when I saw particularly the National Center for Biotechnology Information, NCBI, which is sort of the go-to place really for biomedical genetics, genomics information writ pretty broadly, it occurred to me that what we needed in agriculture was an NCBI. And so ever since then, pretty much, I've been trying to figure out how could we actually make this happen? And what we're working towards now is building that NCBI for agriculture. But of course, that means being able to talk across all of these different repositories and being able to realize a value proposition and being able to bring our funders along. Because I think one of the lessons that I drew from the NCBI experience and from the biomedical experience in general was that deposition rates of even publications, let alone data, were pretty low in the 80s, even in the late 80s, until NSF and NIH mandated that their grantees would make their final research outputs open, through PubMed for the publications and through many of the databases that NCBI maintains, and that's only grown over the last 2.5, 3 decades. So we're sort of in the 80s for where NCBI was, for those of you who are familiar with NCBI, but that is kind of the vision, and I fully recognize we can't take all of the lessons. But one of the key things for us, I think, in agriculture particularly, is that being able to enable this kind of culture change, because it is culture change, in getting people to value and adopt common metadata schemas and some of the other pieces that I'm going to talk about briefly, is for the donors themselves to also put pressure. I want to say, I shouldn't say put pressure, but it's a carrot and stick approach. I mean, to offer the carrots to grantees, and to make sure that they understand there are consequences of grantees not making data open, available, fair, however you want to couch it. And I think we're there now. We're sort of building towards that perfect storm, because for CGIAR, our three most important grantees, Gates Foundation, USAID, and DFID, the UK aid in the UK, all have very mature open access, open data policies, and are increasingly, requiring that grantees adhere to those. So I think we're in the now. If we can make it easy for that to happen, I think we're probably going to be seeing some success, and we already are, as I'll show you in a minute. I talked about the CG Core metadata schema. I talked about the donors and their role in this. Some of the softer stuff that we're doing is also trying to initiate conversations at centers, discussions about how should researchers be evaluated. Typically, we evaluate scientists, researchers, almost solely on the strength of their peer-reviewed publications. Is that enough? Given that Gates put $5 million into the, they awarded us $5 million to initiate the open access, open data work, clearly that's not going to be enough. This is something that our funders are seeing as important. It is, CGIAR outputs are seen to be public goods, so we need to get them out there. So for that to happen, researchers need to be evaluated differently. So that's a clear message that needs to also filter to the centers. I know that GODAN is also sort of buying into that, has bought into it. There's no question, I think, about that. But they're trying to reinforce that message as well, both with the donors as well as with people that they work with, including some of our centers. So I think, again, this is kind of the perfect storm. You have to approach this from a multiplicity of ways. There is no silver bullet to this, but there are, in combination with all of these other softer cultural approaches, we see our role in big data and through the Open Access, Open Data Initiative as showing people what the value proposition is behind making their resources open. They have to see that, what's in it for me. And we need to make it simple for them to adhere to it. Otherwise, we're not going to, it's not going to work. So one of the other pieces of what we're trying to do is to create an agronomy management system, the agronomy field information management system, or AgroFIMS. It's a kind of a kludgy name, but maybe it'll change as we go forward. But this is, again, an effort to address data collection at the beginning and not at the end. And sure, there are some proprietary solutions that are out there, but they typically tend to be for precision ag kind of scenarios. And we work with small farmers, in some of the poorest parts of the world. Those kinds of solutions simply don't cut it for us. So this is an effort that is based on an ontology. So we first built an agronomy ontology, and on the field book is now being created on top of that. And in fact, one of the people who's working on this is somebody I worked with very closely when I was working at Cornell on a semantic web application there. So this is something that we see as as very much leading to RDF, which I'll talk about later, what that is. But to very flexible ways of handling data, let's put it that way, and being able to play on the linked open data cloud, essentially, ultimately. So there's a semantic database that underlies this thing. We're still in the process of building it. The crop ontology and the agronomy ontology will underlie this, and any other ontology really that we want to, that we can bring to bear here. That's relevant. So this is a work in progress. There's another fieldbook effort that's more mature at one of our centers, SIP, the International Potato Center based in Peru. They are primarily, they've designed their fieldbook for breeders, potato and sweet potato breeders and banana breeders, not so much for agronomy, but there are linkages there and there are commonalities. So we will be collaborating and bringing those two efforts together as we move forward. I mentioned interoperability in the FAIR, findable, accessible, interoperable, and reusable. when machines communicate, I mean, when machines exchange data, when they communicate, we are assuming syntactic interoperability. That's sort of more or less a given. But what we're aiming for through the work, I mentioned the semantic web, I mentioned the semantic database that underlies our agronomy fieldbook effort. What I'm talking about here is being able to ascribe the same meaning to words. So when I say plant, do I mean a green plant or do I mean an industrial plant? That sort of, and being able to interoperate at that level is the semantic interoperability. And this is where the ontologies come in. This is where common vocabularies come in. I don't know if everybody's conversant with what an ontology is, but very roughly speaking, it's basically a knowledge system that allows you to define concepts and link those concepts in a sort of a logical hierarchy that makes sense. And typically, each concept will have with it clear definition of what it is, and in our case, how it's measured for the ontologies that we're using. So that in a nutshell is what we're aiming for. So we've talked about metadata and the CG core metadata, which is based on Dublin core, which is mapped to or implemented by all of our repositories. And now increasingly we're moving the conversation towards semantic interoperability, and this is not easy to do. So we've just started with this and with the big data platform, but we're trying to change hearts and minds and make this easy for people to buy into. Just to show you the crop ontology, it's if you search for crop ontology or cropontology.org, you should be able to get there. This is an effort that includes 30-some, I think, crops, the mandate crops of the CGIAR right now. And it has, so there's an ontology for every crop, essentially. So I urge you, if you're at all in the business or interested in harmonizing cross efforts that include crops, to have a look at it. And the way it's maintained is via a community of practice. So this is, I just took a screenshot of the rice ontology to show you what the ontology looks like. So you can see a number of rice traits there, relating in this case to abiotic stress, and in each case there's sort of a unique identifier for that particular term, and a description of the term, a method if there's a method associated with it, if that's relevant, and so on. And it's in the case of this rice ontology, there's a core group of rice breeders who it's a community of practice who see value and realize value from the rice ontology, and so they're maintaining it. They're the ones who initially built it and are maintaining it. So it's quite a successful model in that regard. It's trying to attain perfection when you're talking about an ontology is virtually impossible, but it is something that's a living resource that changes over time and grows and gets modified. I talked a little bit about FAIR, findable, accessible, interoperable, and reusable. So what we're trying to do is I mentioned through the big data platform, trying to enable the discovery of our resources, our final research outputs. I think this situation, what I'm showing you on the screen, is probably fairly familiar to many of you, if not all of you. The 1,000 laptops blooming in the desert, where every researcher, every scientist, data collector has their data, their output sitting on their laptop, and that's pretty much it. Increasingly, as I said, we're moving towards a different model where more and more of those resources are now being uploaded to repositories. But those repositories themselves are silos too. I mean, for instance, the publications repository and the data repository at any given CGIAR center doesn't talk to each other. They're silos, and it's very difficult to find. When you do a search on even on the institution's on the center's webpage, you will not easily end up in the repository. So what we're trying to do initially is to just build a lightweight infrastructure across these silos, across all of those repositories, and expose the resources in a way that's, as far as possible, interlinked, interconnected. And this is where we start building out that NCBI for agriculture, because being able to show data and publications contextually linked is pretty key, I think, and pretty important. So what I'm going to do now is, I hope that the connection will support a live demo. I do have slides, but well, let me go through the slides first, I guess, and then we can go back and reinforce it with the live demo. This is, we now have over 1,200 data sets in series, and we're calling it series nominally. This is very, very fresh off the press. The CGIAR e-research portal is what I'm showing you. This was unveiled in mid to late September, so it's very new and it's very buggy still, but it is a start, and we're continuing to build it out. As I mentioned, the big data platform is a 6-year initiative. We're just in year 1 right now. So this is a first take on it, a pre-alpha essentially. Whoops, that's not what I wanted to do. Hold on. All right. So when I do a search in series for something like maize Tanzania, what you see, I hope you see, is about 2,500 plus publications from across CGIAR, and about over 100, about almost 120 data sets, again, from across CGIAR. You can see the top one from IITA, which is based in Nigeria, IRI, which is based in the Philippines, ICRAF in Nairobi, ILRI in Addis Ababa, etc. So you're seeing data sets and publications. And when you go to any one of these, either when if I were to go to a publication, I would see the DOI, which would take me, I could go directly to the resource itself, or on the page, lower down in the page, I would see related data sets. And if I went to a data set, I would see related publications. There's a little bit of a hit and miss nature to that now that we're very well aware of, that we're trying to improve as we move forward with work on series. But that's where we're headed. It's already harvesting not only from the 30-odd repositories, 15 publications and 15 data repositories, but it's also harvesting from our GeneBanks platform, and trying to show that data in a geographic, in a map sort of view, which I'll show you hopefully in the live demo. But what I wanted to show you, and I told you I would talk a little bit about RDF, and I want you to keep this in mind as I do the live demo as well. Some of this will be duplication, but it's new enough perhaps to some of you that I'd like to reinforce the message. So what we're aiming for is linked data, and we're trying we're trying to enable that through the resource description framework. And let me describe to you what that means. I did a search for maize Tanzania, right? What I'm going to show you is an example of RDF that relates very directly to the rest of the demo that I'm going to show you in series. We have a country, Tanzania, and that country has a village. So there's a village named Long that's part of the country Tanzania. And what this, you see 3 things here. It's a triple, essentially. You're seeing, doesn't matter what the pieces are, but typically parts of a triple in RDF are a subject, an object, as you would in a sentence, and a predicate or a joining part. And the is part of is the predicate or the property that joins the object and the subject. So this is one triple. The village of Long is in the country, or is part of the country of Tanzania. I have a data set that is looking at carbon and nitrogen in the topsoil that's collected from this village, which we already know is part of the country of Tanzania. This data set is collected by CIAT, which is based in Colombia. I could keep building this out ad infinitum, of course, but I'm not. I'm just restricting it to a key part so I can demonstrate to you what I want to show. This data set includes nitrogen content in different plots. So nitrogen content in plot 1 is part of this data set, nitrogen content in plot 2 is part of this data set, etc. It goes on. There's another data set with maize yields that's also collected from this village of Long. That data set is collected by IFPRI, which is the center I'm affiliated with, the International Food Policy Research Institute, based in Washington, D.C. And what that data set includes is the yield of maize in kilograms per hectare that's reported by a large number of households. This particular data set has, I think, over 700, almost 1,000 households, if I'm not mistaken. So there's maize reported by household 1, maize reported by household 2, productivity data, right? There may be another data set for weather that's also collected for this village of Long. That's maybe collected by the Tanzania Met Service, the meteorological service, that sits somewhere out there that I don't know. But even within CGIAR, researchers are not aware that there's a data set for carbon and nitrogen, or whatever it might be, collected for this village of Long. And there's another data set collected by another center, another one of our own centers, that reports on maize yields. They don't know this. So this, if we can expose the data in this format, you're linking things across different domains, different data sets. I mean, the maize data set is in fact a socioeconomic data set. The CIAT data set is an agronomic data set. And we're able to sort of integrate them now through this sort of framework. So there's a sort of a start that to the kind of aggregation integration that we're aiming for. This is not easy to do, but this is an approach that we are trying to enable. And why are we doing that? Because I mentioned linked open data. Well, here's a rendering, a schematic of the linked open data cloud from this year, from 2017. And what you see, that whole big section to the left there of pink or magenta is life sciences information, data or publications or what have you, that exists as linked open data. But if you look at all of these different domains, you see geography, government, linguistics, media. You don't see agriculture. When you look into the life sciences cloud, that part of the cloud, you don't see agriculture there. And yet we can benefit a lot from being able to enable these kinds of linkages, not only across the agronomic and socioeconomic at CGIAR, but health information. I mean, in the end, we're talking about not just productivity and profitability. We're talking about health outcomes, and so it's important to be able to link that with health outcomes that might exist out here in the biomedical domain, for instance, which is part of the life sciences cloud, or part of the cloud. So let me try going to my live demo. And
Medha, I'm just looking at the time, so I'm wondering if you can stop maybe for a second for some questions.
I'm almost at the end of what I want to show. Maybe I'll just continue this way.
Yeah, okay, that sounds good. Okay.
Okay. So what we did with series. Now I'm jumping back into series. What you're seeing is a small part of series. There's a sort of a what if part of series of the platform, where we essentially took a couple of data sets and we RDFized them, right? So we converted the data to RDF, and we are now able to answer questions like this. Give me all maize yields for Tanzania under no fertilizer and complete fertilizer. Give me yields of improved and not improved maize in Long and Matufa. Long is that village in Tanzania. Give me average yields of improved and not improved maize reported by households, along with average carbon and nitrogen content in the topsoil in Long and Matufa. So if I look at what I've got here, Let me just go to this. This thing is getting in the way. Here we go. So if I look at these queries, I don't know if you can see that. I'm going to try and move this somewhere innocuous, like there. I can type in something like, I want to know about maize cultivation in Tanzania, and click on integrate data sets. And then I can select a question. Say I say, give me yields of improved and non-improved maize in Long and Matufa, which is that question I just said. Sparkle is sort of the query language that operates in this domain, works with RDF. And I can execute that query. And what I should be able to see is the yields of improved and not improved maize in those two villages. And what that quickly allows me to see is there are two outliers here. So it's a way of also looking at data quality, in a sense, to be able to do this. Yeah. Now imagine if all of my data in series was RDFized, and I could do this kind of query across the entire pool of data. That's all of those 1,200 data sets. That would be tremendous. I mean, this is what we're aiming for. We're nowhere near it, but that's where we're going. Yeah, and then the last thing I want to show you is this.
Medha, we're not able to see your demo. We're still looking at PowerPoint.
Oh, you're not?
Yeah.
Okay, that's weird.
So the screen is still sharing off of your PowerPoint.
Okay, sorry. Here, you should be able to now see it. You see it?
Nope, not yet. Oh, there it is. Yep. We're good. Yes, we can see.
So what I was talking about earlier, question number 2, is give me yields of improved and not improved maize in Long and Matufa. I've executed that Sparkle query and I get a visual there. If I execute the Sparkle query on give me average yields of improved and not improved maize reported by households, this is that IFPRI data that I showed you, the example in RDF, along with the average carbon and nitrogen content in the topsoil in Long and Matufa, here's what I get. So now remember, I'm integrating data sets from across 2 different centers, 2 very different kinds of data, and putting them together based on the fact that they were both collected in Long. This is not easy to do otherwise, but I can do it if that data is converted to RDF, and I can visualize it through series very quickly. So I guess I'll stop there. I just wanted to give you a flavor of how we started out, what we try to do to move along the path of open access, open data, and where we are now. So I'll stop with that, and I welcome questions, I guess.
Okay, so I'm going to start out, and I know Martin has a question around FAIR, but we have of the people who are online, most of them are librarians, and I'm wondering how they can help. Well, first of all, your platform that you've shared is using the research data from CGIAR. So do you have are good ways for librarians and ag researchers to connect to your big platform with their data in other ways?
And thank you for asking that, because I forgot to mention it. Right now, we're calling the CGIAR e-research, but by no means is it meant to be just CGIAR. So by the end of the year, we will have an upload data capability to this, so that anybody who wants to upload data will be able to do that. If not by the end of the year, then pretty early next year. So that is definitely on the docket, and it's primarily first of all, we don't want to build something that's only for CGIAR. We want to democratize both access to data as well as the ability to upload data. So that's the big push, particularly with a view towards our partners, many of whom are in developing countries who don't have the resources, either human or capital, to build their own repositories, et cetera. But that certainly goes for researchers in the US and for universities across the US or anywhere else. Anybody who wants to upload data to this will be able to do this very quickly, shortly.
So, just so I understand, if there's some research data that let's say an agronomist here at Auburn has, and he has a good place, or she has a good place to put the data in a repository either here or maybe a subject matter area. Is there a way to link it to CGIAR, or do they really need to upload the data?
No, you can link it. So we just need to know that you're interested, and we need the APIs, and just basically be able to make that happen. I'm simplifying a little bit because, of course, the schemas have to match, but I don't think that that's a huge amount of work. I mean, for the most part, I'm assuming repositories that are interoperable to that extent, and can work in that way.
Mark has asked a question in chat, and if I need to open up your audio, I can do that, Mark. I'm also going to open up Martin's audio so he can ask his question and also chime in as he wants to.
Okay, so I see Mark's question, the API available for this data. Well, there is. I'm not sure how well it works yet, but you can try it. And I would love feedback, actually. I would love to know what it is that people are looking for. We are trying to build use cases. We're trying to identify what kinds of data sets might be priority data sets, or what kind of data might be priority data that people might want to go after. So that would be very helpful for me to hear back from you.
Let's see. And so, Martin, you asked a question early in the chat, so you want to kind of talk about that and then give us other information or other discussion points here.
Hi.
So let me just finish. Mark just asked if I could email him. I'll try to remember to do that, Mark, but my email is also on the presentation at the very end, I think, or the very beginning, one of the two. Feel free to email me, and I'll try to remember to contact Anne as well. Sorry, Martin, go ahead. Hi, first of all.
Hi, Medha. We know each other very well.
Yes.
Now, I was probably being overly pedantic, but I know that some of the terminology around open data can sometimes be confusing to the uninformed, and the difference between open and fair sometimes causes confusion within some of our audiences. Is my understanding correct that fair and open are kind of sister definitions? We usually try to talk about things being fair and open. And indeed, isn't it the case that you can have fair data that isn't actually open?
You can have fair data that's not open, but the accessibility, if you're actually ticking yes on accessibility, on all the principles. I mean, there are these 16 principles that we generally go by. So it depends on how many of those principles you're adhering to. The problem with open was that people were putting up PDF files of data and saying, well, I've put it up, it's open. So that wasn't cutting muster either. So when the Dutch team, I guess, came up with the concept of fair, that seemed to be something that was very helpful to our in terms of operationalizing open. What do we mean by open? What is it that we want? We want data to be reusable, interoperable, and yes, we do want it to be findable and accessible. So if you can get to ticking each one of those four principles for each one of those F, A, I, and R, roughly four, you're going to be open in the sort of the information specialist type definition of open. But it seems to help get away from this, oh, I put up a PDF into the repository and therefore I'm, open. Because, I'll tell you, there are a lot of data sets that are PDF files right now in our repositories that we need to go hound the folks who have done that.
Sure, thank you. And as I say, it kind of might sound a little bit pedantic, but I suppose a lot of this discussion around fair has been very interesting to us, because a lot of businesses are now talking about creating fair data that isn't actually open. So I think, from your perspective, you want both. You want fair and open. But yeah, as I say, there's a lot of businesses that are talking about making data fair because they want to bring people to that data to kind of maybe give you a taster of it, but actually if you want to receive it in full, then you're potentially going to have to pay for it.
Yeah, and that is the downside of it. So I guess there is, there's no real, I mean, you don't really win when you just stick with open only either. That's what we've discovered. And couching data as fair is a little bit more helpful in going forward. But of course, what we ultimately want is we also want them to include clear licensing that allows the data to be reused. So the reuse part of that is also where we get towards the openness, how open something is.
Thank you.
Yeah.
Sure.
So Medha, again, we have I think several librarians on the call, and I'm wondering if you have some advice for them as they're working with faculty, and maybe some of the faculty are not attuned to how to make their data open in a way that is discoverable and so on. So how do you have advice for them in working with them and getting the right ontology and getting some of the good practices that you're talking about in the data?
Well, I'm not necessarily pushing for the use of ontologies per se. I mean, I think it depends on what you want to do. If you're trying to get researchers to upload into the institutional repository, ideally your repository will be, will adhere to some standards. I mean, to allow that kind of interoperability, which shouldn't be too difficult to manage. But I think the key thing for researchers is again to answer the question of, you're asking me as a researcher to do more work, and I don't have the funds necessarily to spread. I don't have the funds to hire a data curator in a blah blah, but whatever I might need. So unless you're going to make it really easy for me, and unless you're going to show me a clear value proposition, why should I do this? So being able to answer the question of what's in it for me and make a persuasive argument there, being able to point to donors, to funders who are increasingly asking for this. As I said, in the biomedical world, that took off after NIH and NSF mandated that publications and data be made open through their repositories. And then the third piece, of course, is some handholding support from the libraries themselves. I've long thought that librarians and libraries are absolutely the right people to work in this domain. I mean, I think as we move increasingly away, unfortunately, from real books, and libraries full of books and managing books, the management of digital resources and helping researchers make this happen is really where libraries should be. It's something that I've been trying, I was saying that at Cornell, and I'll say it again. I mean, I think librarians are absolutely critical in this, and need to sort of, take that on perhaps as a role. But what that also implies is some level of subject expertise, domain expertise, because without that, you can't really handle the data.
Right. Good. Thank you. And there is a question in the chat from Deanna. And so can you see the chat, or do you need me to read it for you?
Are you looking at real-time data collection versus what I heard you talk about as upload a file of your data? So real-time data, oops, sorry. For instance, we collect real-time data on harvestability of crops. Here, we have the previous year's data, but it is really more useful for our client. Yes. We would love to have real-time data, but typically we're talking about agronomic experiments that run through multiple seasons. So for them to be ground truthed, you're talking typically 3 seasons. If maybe able to get by on 2, but it's hard enough to get researchers to upload their data at the end of the project, which tends to be 3 seasons, because of course they want to publish first. My data, I'm afraid that I'm going to get scooped if I put this up. So I'm going to, publish first, which takes time, and then upload that data. But increasingly, I think Gates particularly is wanting real-time data. So that is going to become more and more important. For weather information, that can be real-time, but that tends to be handled as a sort of security, security issue very more often than not by countries. So it's hard to get to weather data in real time. It's hard to get to, our models aren't good enough to have long-range forecasts, which is what's really important. So, those are the kinds of things that, so in short, I'm rambling on, but in short, I agree with you, Deanna. I just don't think we're anywhere close to it. It's a battle to even try and upload data that's been being after 3 years of a project. So we're still a ways from that point. But as we move forward and we show people that sky's not going to fall down if they make their data available, they're not going to get scooped. In fact, citations are likely going to go up if they upload their. That's the other thing. That's the other a piece of information to possibly take to your researchers is show them the information. There are papers there that show that actually citations go up when you make data open and available. So these are the kinds of pieces that you need to sort of go armed with a package to researchers. But in short, I agree with you, Deanna, but we are not there, and it's going to be a while before we get there.
We're at the top of the hour, and I, those who need to go ahead and leave, and that's fine. We are getting a few more questions in the chat, so I'd like for you to be able to answer those. But before everybody leaves, here at Auburn with the PUSH organization and our partnership with GoDan, that we are really wanting to open up the discussion around how universities can help faculty members make their data open, and also to recognize and discuss the challenges around doing that. And so one of the challenges, I think Claudia or somebody had said, is the amount of resources around that are available for libraries to help their faculty. If we're going to continue this discussion with PUSH, and we hope to be able to connect with you in other ways. So Medha, do you want to, I think there's another comment that Claudia has, or question there. Maybe you can see.
Right. So in terms of the limited funds and expertise, I guess what I'm advocating for is over time, hiring of librarians who also have subject expertise for certain key roles, at least, because one of the things that's been happening over time is the librarians are not librarians, but libraries themselves are trying to figure out in what areas can they still remain relevant, given that we're increasingly moving towards digital, into the digital world of digital management of books and resources. Well, I think this is a very key area where researchers are crying out for help, and I recognize that resources are shrinking, but maybe arguing for being able to help researchers in this way might in fact open up more funding, more resources. Being able to fund a data curator out of 5 different research projects, for instance, 0.2 FTE from each project. That may be a model that's worth putting out there. I'm just throwing out possibilities, because over time, I think libraries are going to have to change what they do for businesses and how they support academics. In terms of what's in it for the researchers, absolutely. I mean, I think what you've said about additional funding, additional collaborations, additional citations, those are all, points that need to be brought to bear when you're making the argument for researchers to be able to share data, as well as pointing to other domains. The ecologists have done this with their long-term ecological trials. Certainly the biomedical world has been sharing data for decades, and it hasn't collapsed. I mean, that's enabled sort of a transformation in medicine. The kinds of therapies that we have access to now probably would not be possible without the data sharing that has happened over the last couple of decades. And in order to really, I mean, I guess it goes to the heart for me, the argument that I make with some of my recalcitrant leaderships and scientists themselves is, okay, so tell me then, why did you join CGIAR? What motivates you to be here? I mean, what is it that you're here for? Darn it, you know. I mean, are we here just to get money, publish, and advance? I mean, fine, if that's what your business is, that's okay. But most people will stop to think and realize, no, wait a minute, I do want to have an impact. I want to be able to enable innovation. I want my data to mean something after I've published. You know, so I think getting people to think in different ways is really important as well.
This has all been very good. I really appreciate your thoughts, and your passion is really coming through too. So, I like I said earlier, PUSH is going to continue some conversations around open data, particularly for universities, and we're doing some assessment, and we're learning some things that you've shared. We have learned that there are more opportunities around the medical field and pharmaceutical areas than what we're seeing in agriculture, and so it would be nice one day to be at that same level for sure. We appreciate your time, and I know it's in the evening there, and this has been very, very good for us at PUSH, and I'm sure for those of the attendees that have been online. Martin has also shared some information from about GoDan, which is one of our partners as well. Medha, thank you so much for your time, and thank you all you attendees who are still hanging in there. We appreciate your attendance, and I left my email in the chat, and if you have any thoughts either about the webinar or about other ways we can connect and talk about these things, please send me an email. Again, thank you, and Medha, we will also be putting the recording of this and Medha's presentation in a website called learn.extension.org, and I will put that in the chat right before I close out. So.
Thank you, Anne. Thank you to all of you who attended, and thanks very much for all of the questions. They were interesting, and with all the questions I get when I do these kinds of things, it forces me also to think and to figure out what we should be doing differently. And as you go, you think more about the presentation, you look at it, please feel free to write me. And if anything occurs to you, or if you have, suggestions or ideas, I'd welcome them. Okay. Thanks very much, guys. Thank you, Anne, and your team. Take care.
Bye-bye.
Bye-bye.